who's ever suffered severe pain and has tried to describe this experience to a friend or a doctor often finds themselves at a loss of words. Now, this isn't because the words don't exist, but because, fortunately, they're not used very often and they might sound absurd. So someone that has experienced a great pain might say something like, "It felt as if I was being stabbed with 1,000 hot knives and someone was slowly twisting these." Metaphors and as-if statements are needed to convey the experience. But what if I told you that our perception of pain is not just subjective, but biologically different from person to person? So this is what I've been studying in my PhD, the neurobiology that underlies the extreme variation that we see in how people perceive pain. And today I'm going to share some of these fascinating findings. So in my research, I have used a variety of different neurophysiological techniques to examine the brain in pain. Specifically, I've focused on the cingulate cortex, which is illustrated on the figure above. Using magnetic resonance spectroscopy, we can look at neurochemicals in the brain non-invasively. Key findings suggest that increased glutamate is related to increased pain sensitivity. This was evidenced by my systematic review of the literature, as well as in an experimental pain study, where I found that glutamate increased 8% in the more anterior portion of the cingulate. And interestingly, this response was higher in women compared to men. Now, in another study, in an attempt to more closely mimic clinical pain, I used a heat paradigm, and I applied this every day for 4 days to participants. I looked at their electrical responses of the brain, measured by EEG, and I found that these were enhanced compared to baseline. Now, glutamate levels in the more posterior portion of the cingulate cortex are related with this enhanced electrical activity. Now, lastly, using arterial spin labeling, a technique that allows us to look at blood perfusion, so perfusion just being the exchange process of oxygen and nutrients from blood to the tissue, I observed that women have higher perfusion levels across the cingulate cortex compared to men. Now, this has been related to increased pain sensitivity in previous studies, and it may be an underlying difference that explains why women are more sensitive to pain. Overall, these findings provide insight into the neurobiology of pain and have implications for individualized pain management strategies, as well as the development of sex-specific treatments. So this type of research has the potential to have a profound impact by giving us a sort of biological language of pain, reducing suffering and improving treatment outcomes. Thank you.